Alors, le rôle de l'ESITC de Caen dans ce projet est multiple. Je peux le résumer en 3 étapes. La première étape est la sélection des matériaux. Alors, c'est des matériaux en fait qui sont sélectionnés en partenariat avec nos collègues anglais et nos collègues français. C'est des déchets bien sûr et c'est des matériaux aussi plutôt biosourcés. Il y a une deuxième étape, la deuxième étape est en partenariat avec l'université de Brighton en Angleterre. Elle consiste en fait à analyser en fait des mini-prototypes qui seront testés au sein de notre laboratoire. La troisième étape, elle dépend de la deuxième étape, c'est les prototypes à grande échelle. Donc, ce qu'on va voir par la suite, c'est des prototypes en fait qui sont de grande dimension, 2 mètres par 2 mètres, à échelle 1, taille réelle, qui seront testés dans nos champs climatiques et on va tester thermiquement le comportement de ces prototypes.
So I was approached by Brighton University. They're looking at a number of insulation type materials for the waste house. They approached me to see whether or not there were any materials that were available from our household waste recycling sites that we operate. And having looked at a number of different materials, we ended up focusing on quilts.
Donc notre prototype, il se base sur 2 matières premières. Donc la première, c'est du polyester issu de déchets de couette. Et la deuxième matière, c'est du bois OSB.
We met with Veolia, who are the local waste procurement people, and we just asked them a simple question. We said, what's the most pain in the neck, problematic textile that you have to deal with that you cannot recycle or reuse at the moment? And they very quickly said, bedding, duvets and pillows. None of that is ever recycled for many reasons. So we collected bedding. And the great thing about duvets is that they are already insulation. They come with a TOG value. And so we don't have to reprocess them at all. All we have to do is to put them in a correct way, have to install them in a partition in a wall, and we have to then measure their performance.
I think Veolia have been really beneficial to the project. They checked our ideas and validated that actually this was a problem, and they've been really helpful in terms of us collecting the samples that we had in order to understand really the composition and the quantities of duvets and pillows being generated. So for a week on the household waste site just down the road, they set aside all the duvets and pillows, and just for 1 week there was over 300 litres of duvets and pillows that they collected. So that's just from 1 week from one site.
One of our key sort of principles is about innovation and looking for new ways of dealing with difficult products. So something like this fits absolutely with something that we look at in terms of finding new outlets, new markets, working with local groups in order to find new ways of dealing with difficult materials.
Alors, pour déterminer les propriétés thermiques des matériaux de construction à échelle réelle, on a souvent recours à la méthode de la boîte chaude gardée. Les tests avec cette méthode consistent à placer une paroi caractérisée entre 2 ambiances, une chaude et une froide, et à mesurer le flux apporté pour maintenir une différence de température constante entre les 2 faces de la paroi.
On a testé les mini-prototypes qui ont la même composition que les prototypes mais en petite échelle. Et les résultats que nous avons obtenus sont des résultats encourageants. Donc on a obtenu de bonnes performances, notamment sur le plan thermique. Donc on peut dire que ce matériau-là peut servir dans le secteur du bâtiment en tant qu'isolant.
The duvets are sort of pliable and soft, obviously, so we found that they could be stuffed into timber voids with staples to hold them in place and stop them slumping. But we are actually, for this project, we're going to test them in several different ways to test their performance.
The big challenge we have in the industry, we met the challenge when we designed and built the waste house, which is how on earth do you work with second-hand materials, because where's the guarantee of performance of that material? So the provenance of the material is a big deal, and that's a challenge. The other challenge is just the space to store the materials coming off sites where buildings are being deconstructed, the sort of networks we need to make people who are building buildings aware that buildings that are being deconstructed could be a source of material. And we've really got to retrain our designers to have that mindset of working with second-hand stuff.
the circular economy is absolutely fundamental to our business. It is part of our core. So being involved with this particular scheme is really great because it's an innovation. It's absolutely something that we're interested in. Obviously, if there's an opportunity to commercialise it and scale it up, it's absolutely something that we'd love to be involved with.
With Local Works Studio and our other colleagues, we've developed these external hanging tiles that are going to protect the duvet prototype that we've got at the waste house. And they're being made out of waste construction material, namely brick and concrete, from the Preston Barracks site, but really interestingly mixed in with oyster shells from a local restaurant, which just this one restaurant throws away 50,000 oyster shells a year.
We wanted it to be 100% waste. So we didn't want to sort of find a waste aggregate and then combine it with a concrete or cement binder.
I think worldwide there's over 7 million tonnes of mollusks are thrown into the oceans every year. Meanwhile, and by the way, sorry, those oyster shells and other mollusks, they're basically 90% calcium carbonate, which is what we make cement out of. So we can use these shells to make cement.
So these oyster shells are actually chemically very similar to chalk, to limestone, calcium carbonate. If they are fired, if they're burnt up to about 1,000 degrees centigrade, it turns chemically to quicklime, to CaO, calcium oxide.
So for example, looking at the materials we've identified thus far, these materials are quite not entirely unique, but they are quite peculiar to Brighton. And so to utilise these materials that are on our doorstep and turn them into something that's quite specific to that place has value. The provenance of these materials is something that generates a level of meaning. And when we recycle the physical materials, we can quite often sort of recycle the meaning of those materials as well.